For me, cybernetics is about systems that learn to adapt to a world that can always surprise them. I have possibly a different understanding of cybernetics from a lot of people. I think historically cybernetics began as a science of the brain. The important key cyberneticians in the first generation were almost all brain scientists of one sort or another. People I've written about in Britain were Gray Walter and Ross Ashby, who worked in psychiatric milieu. In the States, the permanent chairman of the Macy conferences, which is where cybernetics got going in the States, was Warren McCulloch, who had also worked in the psychiatry department at the University of Illinois and was very interested in how the brain worked. The big name who made cybernetics famous was Norbert Wiener, but he was the exception. He was a mathematician. He didn't really know anything about the brain. The key thing you have to realize if you want to understand the specificity of cybernetics is that the cyberneticians understood the brain in a particular way. They understood it as a performative organ. The brain was something to do with what we do in the world. The contrast is with what is possibly a more familiar notion of the brain as the organ of thought. The artificial intelligence tradition as it developed in the second half of the 1950s elaborated the idea that what brains do is think. But the cyberneticians elaborated the idea that what brains do is they help us get along in the world, help us to perform. Beyond that, the key notion of early cybernetics was that the brain is an organ of adaptation to the unknown. It's the brain especially that helps us get along in situations that we haven't encountered before. That vision of the performative, adaptive brain is what was developed in a very long tradition of work in cybernetics, especially in Britain, and it's the British cyberneticians who I've looked at in most detail. I could add that the way that the British cyberneticians elaborated this image of the brain wasn't to write about it. From the very start, they tried to build models of the adaptive brain. So this tradition of cybernetics is a special kind of tradition of robotics. As it grew over the years, the cyberneticians went beyond the brain to study and construct adaptive systems across all sorts of fields. This interests me a lot. So you find cybernetic approaches to the arts, as I said, to psychiatry, brain science, but also to management. It extends in a certain way into complex systems theory, education, architecture, music, and even spirituality. Why should we study the history of cybernetics? I have studied it to find inspiration. The projects that the cyberneticians engaged in are things that I could never have made up. Many of these projects are very strange and imaginative. Fascinating kind of work in robotics, which is very important today, not just in the past. Strange approaches to psychiatry. This runs into the anti-psychiatry movement. Very different ways of understanding madness, different ways of understanding the self, different ways of trying to help the mentally ill, etc., etc., etc. These are all very unfamiliar ways of going on in the world. So I look at cybernetics for a kind of inspiration. I'm not sure that my book is a history of the future. That would be a funny way to read this phrase. I like this phrase, sketches of another future. It came to me one afternoon in California and I thought, I'll call my book that. Because it sounds numinous. It conjures up, the possibility of difference. And that's what attracts me to the history of cybernetics. I'm not interested in the history of cybernetics in an antiquarian way. I don't want to document every single thing that could be called cybernetic. I'm interested in the projects that I talk about in the book as exemplifying the fact that we don't have to be in the world in the way that most of us are today. Right? We don't have to, we don't have to treat nature as a kind of passive standing reserve, as Martin Heidegger calls it, just waiting. It's not just out there for us to use up, use and use up. We don't have to be controlled modern selves. Maybe the modern self is part of the problem. Maybe if we understood ourselves differently, we'd be a bit slower to go out and bomb people in faraway places with strange-sounding names. One can say all this, but then the question is, well, if we're not going to be who we are now, who else can we be, right? And I understand what I wrote about in the book as examples of the fact that we could be some other way. This is why the strangeness of these projects speaks to me. They dramatize the fact that somehow elaborating this notion of the performative brain and the ontology of inexhaustible becoming conjures up all sorts of real other ways to be in the world. It's not just a pious hope that there could be other ways. And so these projects in the past that I look at, I'd like to think of as models for new projects in the future. We don't have to do the same as Stafford Beer did in the 1960s, but once you've seen enough examples, the invitation is to go on like that. Right? And to finish this line of thought, I mean, the idea isn't to absolutely exterminate our hegemonic ways of being and thinking in the world, but it's to show that there's a practical alternative, and to show that there are different ways of going on in the world, as it were, denaturalize these elements of the modern world, which seem to me to become increasingly grim and fearful. I think it's very hard to be optimistic about the future now. I mean, when I was growing up in the 1960s, everybody was optimistic, but optimism has disappeared. So the idea is to kind of denaturalize this grim and fearful way of being and to conjure up a possible alternative. I understand cybernetics as being a very different paradigm from modern science and modern engineering. It's a different way of going on in the world in Thomas Kuhn's sense. So I understand all of these cybernetic projects as somehow extending the field of our imagination. That's the sense in which the subtitle of my forthcoming book is Sketches of Another Future. I could give you one or two examples. The wildest project of all that I've ever come across was known as biological computing. The idea of biological computing was to enroll the powers of nature into human projects. Especially in the early 1960s, two of the people I've looked at, Stafford Beer and Gordon Pask, tried to think how they could enroll naturally occurring adaptive systems that you find in nature, to manage factories and organizations. The idea was to get rid of the manager and to plug in some adaptive system in their place. This adaptive system could be a colony of mice or a colony of insects or a pond, some kind of complex ecosystem. And the idea was that just as a manager keeps the factory or the organization in balance and responds to fluctuations, well, ponds and ecosystems do that kind of thing anyway. And beyond that, if the environment changes drastically, an adaptive system can cope with that. A manager might decide, well, we'll produce a different kind of product. And the fantasy was that a pond responding to a change in the environment would do the equivalent thing, if you could couple it to the factory or the organization properly. It was making that coupling that was exceptionally difficult. Another example would be from the field of the arts. Gordon Pask, one of the people I studied, made many strange and interesting and unexpected contributions to the arts, theatre, and architecture, all along the theme of adaptation to the unknown. His first project was a machine called a musicolor machine, which turned a musical performance into an electrical signal which modulated a light show. And the important thing was that the relation between the music and the lights wasn't a linear one. It wasn't that you press this note and that light comes on. It was a non-linear one. The machine, the electronics would change, the thresholds for various effects would go up and down, depending upon the previous history of a particular performance. The machine, as Pask used to say, would eventually get bored. It would stop responding to specific stimuli. And in getting bored, it would encourage the human performer to adapt to it. The performer had to try something new to kind of wake up the machine and get it performing in a lively way. So a musicolor performance was a kind of reciprocal adaptation of the human and the machine in the joint production of a performer. Presumably, I don't need to say how strange that is. You know, it's very hard to say what a musicolor machine was, right? And this goes for many cybernetic projects. The objects involved just don't fit in easily into the conventional classifications. Pond never did manage to manage a factory. It was a brilliant idea, but as we know, there aren't any factories managed by Ponds today. The question that we need to think about is, why did this project fail? I think there are two angles to this. One is, and this is an interesting fact about the history of cybernetics in Britain, that this biological computing project was carried on in the spare time of Stafford Beer and Gordon Pask. Stafford Beer was running the operations and cybernetics department of what was effectively British Steel in his paid hours, and in the evenings and weekends he would mess around with biological computing with his daughter. At one point he wrote a kind of summary article in 1962 saying something like, it would be unreasonable to ask my employers to fund this work. What I really need is, somebody to give me a lot of money to pursue this project full time. Nobody ever gave them any money. If the development of digital computers had been carried on Saturday afternoons by two amateurs, we would not have any computers, right? So partly it's the question of just the lack of support, which points again to this marginality of cybernetics as not fitting into any recognized institutional world. And the other problem was how to make these biological adaptive entities, ponds for example, care about us. So what's important in the factory, let's say it's materials flowing through the factory and profits that are generated, something like that. How do you turn those quantities into some kind of quantity that the pond will care about, that will act upon the state of the pond so that the pond can act back upon the factory? And it was that coupling between the human world and the organic world that they never quite solved the problem of. One of Beer's ideas was that he had this tank full of larvae, Daphnia, maybe you know what Daphnia are, little tiny pond insects. And he had the idea of feeding the Daphnia with iron filings so that they would absorb the iron filings into their cells, and that he could then communicate with them via magnetic fields. So the magnetic field would register the state of the factory, and this would do something to the Daphnia, and the Daphnia would react back in the factory. What happened was that the Daphnia would just excrete the iron filings so that the water turned this awful rusty brown and impenetrable to magnetic field, and it just didn't work. But if you had the the British military research and development budget behind you, you could have probably done much better than Beer did. Yes, that's a very interesting and striking question. You know, it's interesting and striking in the sense that it never occurred to me that one can go on in the world without objects and technologies. If you think about what happens in the world, almost all of our activities are saturated with machines, gadgets, and things like that. So I've never found it surprising that objects, strange objects like the music-color machine, were an integral part of cybernetics. The only way you can find that puzzling is if you work in a university and you think that the only important thing in the world is ideas. We academics deal in language, words, we teach our students to use words properly, and the social sciences and humanities are essentially a body of words. So if you try to think of cybernetics as being another social science, then you'd have to say it was a very odd kind of social science because the objects are there. I come at it from a different angle. I'm very interested in the worldly projects of these cyberneticians, artworks, the kind of interactive theatre, trying to understand the brain by building models of it. And there it doesn't seem terribly surprising to me at all. What this means, of course, is that it's one respect in which cybernetics didn't fit in well with the established world of the modern university, precisely because it wasn't just words. So the centre of gravity of cybernetics was not in the university at all. And this goes with the strangeness of the cyberneticians' projects too, because they were interested in the kind of adaptive couplings which might link human beings to the material world. So for them, the human being wasn't the centre of everything. The cyberneticians were not humanists. They didn't centre all of their accounts on human beings the way mainstream social science, the modern humanities are humanist. So both materially and conceptually, the cyberneticians were marginal to the academy. And I should say that these weren't just any old objects that the cyberneticians were concerned with. And if I had to characterize peculiarly cybernetic objects, it would be as unusually lively machines. So one of the founding objects of British cybernetics was a little robot that Grey Walter built called the tortoise. And the tortoise would navigate itself around the world looking for lights, and if it found them, it would head up towards them and stand there and admire them for a while, and then it would get bored and wander off and find another light and things like this. These machines were roughly shaped like tortoises too. And they conjured up a kind of sense of wonder. People found them to be kind of quasi-magical objects. They were instances of technology behaving badly. That printer there is just going to sit there, it's not going to do anything. But these things were like cats and dogs, and they wander up to people in meetings. They famously were attracted to women's legs at meetings probably because the women were wearing nylons in the 1950s and the lights were reflecting off them. So these very lively machines were the focus of cybernetics. The music-color machine was a lively machine. It acted as if it had a will of its own. So these were machines that, in their very behaviour, tended to dissolve the boundary between the living and the dead, the animate and the inanimate. Which, again, how do you fit objects like that into the kind of humanities and social sciences and these? The first generation of cybernetic work, especially in Britain, as I said, focused on the brain. People built small robots and machines to emulate the processes of adaptation that they associated with the brain. In a sense, these robots were scientific models of the brain. They contained certain mechanisms that help the robot engage with and adapt to the world. And the suggestion was that our own brains have similar mechanisms inside us. Not literally valves and resistors and capacitors, but the functional equivalents of that kind of thing. This was a way of elaborating a very strongly materialist understanding of what the brain and the mind is. There's nothing but these kind of adaptive mechanisms. That way of thinking continues today, although the modern understanding of the material brain is more chemical than electrical. I'm not sure what it teaches us. I mean, it's quite a frightening prospect if you contemplate it. It makes you feel like you are one of those little robots. And that's very disturbing if you take it seriously. I mean, it is very disturbing. But in a way, that's what these robots teach us about ourselves if we accept them as models of the human brain. And of course, there was a big reaction against that, which takes the form of pointing to uniquely human capacities of the human brain. This is what I call human exceptionalism. The history of the social sciences and the humanities since the Enlightenment seems to have consisted of fixing on properties of the human that make us special and distinguish us from everything else in the world. So, the critique of the cybernetic brain models would be, well, first of all, they can't think, they can't speak, they can't fall in love, if you think that's a definitive, they're very... So the essential features of humanity are just not there. That's one way of resisting this message of cybernetic. But there's something else that they can teach us too, I think, which doesn't entail being obsessed with these things as models of the brain. What all of the cybernetic machines that I've looked at staged was a kind of sensitive interaction with the environment to which the machine responds. So the performance of any machine, one of these little robots or the music-ala machine or whatever it might be, is a kind of decentered performance which is elicited by a response to the environment, which invites a response from, let's say, the machine back and forth in what I call a kind of decentered dance of agency, in which neither partner is determining what's going on. I think of these machines and their performances as ontological theatre. They stage a certain vision of what the world is like, what being in the world is like for us and everything else. We are continually negotiating and adapting to the unknown, which is continually emerging in new shapes. And we're part of this process of becoming. That's what the world is like, and we're not at the centre. We don't control it. So there's a kind of ontological vision of what the world is like, which goes along with cybernetics. This is very different, of course, from the modern ontological vision of the world, in which we human beings are the only genuine agents around. We call the shots of history. We make the decisions, and we understand the rest of the world is just kind of passive matter waiting for us to impose our will upon it. Again, this view is echoed in the academic disciplines, and again, the cyberneticians conjured up a very different, strange and imaginative ontological vision, which A, speaks to me a lot, and B, explains why the university wasn't the centre of gravity of cybernetics. There has been an enormous amount of critique of cybernetics. What is the origin of this critique? I can think of... It's taken me a long time to understand this, because the branches of cybernetics I've looked at I find very encouraging and optimistic. This is why I want to speak about them in a forward-looking way. But many thinkers have criticised cybernetics. Why have they done that? There are two reasons I can think of. One is, in the standard origin story of cybernetics, it begins in World War II with Norbert Wiener's work on a machine that he called the anti-aircraft predictor. The anti-aircraft predictor was a gadget that was supposed to track aeroplanes moving through the sky, process the information, feed it to a gun so that the gun could point at where the aeroplane would be in 10 seconds' time. That's how long it takes the shell to get from the gun to the plane. And almost magically shoot down the plane by guessing where it's going to be in the future. That is a very interesting object cybernetically. Again, it could be considered as a model of the brain, the performative brain. But it was born in the belly of the beast. It was born in the heart of military research. It was for the purposes of killing. It looked at from a distance, not being entangled with the war any longer. It seems like a very ideologically suspect gadget. It's a militarist gadget. Most people in the academy are not very keen on the militarism. And one sense of the critique is that, having been born in this military matrix, cybernetics is inevitably tainted by its origins, and we ought to beware of it. I personally don't follow that line of reasoning. I call it the doctrine of original sin, because the cybernetics was born in sin. You know, it's part of fallen humanity, and it always will be. I don't think that's right. I don't think that machines or ideas are inevitably forever associated with their original matrix. I think that's wrong. The other critique of cybernetics is a more wide-ranging critique. If you read the cybernetics literature, for example, you find the word control everywhere. So the subtitle of Norbert Wiener's groundbreaking book was Control and Communication in the Animal and the Machine. The word control was the first word of the subtitle. And you find it everywhere. I mean, the cyberneticians all talked about control. And you don't have to think very hard to see what the critique of this is going to be. The only sane thing to say is we're too controlled already. People are always pushing us around. We need less control, not more control. The last thing we want is a science of control that's going to back up all of the disciplines and controls that are already imposed upon us. That is a very reasonable line of critique, but I don't think it applies to the strand of cybernetics that interests me, that I want to recommend to other people. Gordon Pask, the cybernetician who I mentioned a bit earlier, certainly talked about control mechanisms, but his metaphor for what his machines did and his understanding of what happened in the world was conversation. By conversation he meant a productive, open-ended, unpredictable exchange between two or more parties. He might mean, just a genuine conversation down the pub, but he could also think about conversations between human beings and machines. So a musical performance was a kind of open-ended interaction between the performer and the machine. He built a fabulous artwork, which is shown in London in 1968, called The Colloquy of Mobiles, where a set of 5 mobile robots would have what he would call a conversation between all 5 of them. A conversation that nobody could predict where that conversation was going in advance. He understood, he actually tried to construct the technology of an interactive theatre in which the evolution of the action would take place as a kind of conversation between the audience and the actors. The audience would react to what the actors were doing. Somehow their reactions would be fed to the actors, who would take them into account in deciding what was going to happen next in the action, and so on around these loops. So if you take the conversation metaphor seriously, control in cybernetics doesn't mean Big Brother telling you what to do. It means trying to get productively along with another who you can't actually control, on the metaphor of conversation. So I think I can see the point of the critique of cybernetics as a science of control, but I think it's misplaced a lot of the time because control doesn't mean what you think it meant. Yes, this is very interesting. I mean, I can't give you a full account of it. My interest in spirituality wasn't quite zero before I started this project, but it was pretty close to it, which is a reflection of, growing up in a kind of modern society where we have science and positive knowledge on one hand, religion and spirituality on the other. They're two different realms. And, certainly if you grew up in Britain when I did, the spiritual realm hardly existed. So I'm not an expert on this, and I still don't really know how to talk about it. But what struck me reading the history of cybernetics and looking into it was that it's quite saturated with spiritual elements. There's a lot of kind of Eastern spirituality, Buddhism, even a bit of Hinduism. And the most remarkable thing that I discovered that I still can't fully make sense of is the British cyberneticians were very often associated with spiritualism, seances, speaking to the dead, things like that. They were capable of taking it seriously. Why is this? You don't find this if you look into the history of physics, which is what I wrote about before, really. I mean, you find you find plenty of Christians, but they split the work, the technical work and their spirituality. I think there are many ways of looking at this. The modern ontology is is a vision of the world as a fixed, knowable place. The image of physics is to arrive at this theory of everything, the bottom of the cosmos. There'd be nothing left to say if you found something like that. The ontological vision of the cyberneticians was a vision of the world as endlessly becoming. In the end, the world is unknowable. There's always more than you've encountered. This goes with the idea, connects back to the original idea of the brain as adapting to the unknown. You have a vision of the world as an endless source of surprises. If you think of the world that way, certainly one class of the surprises would be what we think of as spiritual ones. So Grey Walter, one of the pioneers of British cybernetics, was very interested in the feats of Eastern yogi. These people who are said to be able to suspend their heartbeat for days. You can bury them alive and dig them up 6 months later. That kind of performative aspect of Eastern spirituality interested Grey Walter just because he was thinking of the brain itself as a kind of performative thing. My man Stafford Beer did very technical work in management cybernetics, but he also taught tantric yoga. He wrote what seems to me to be a bit of autobiographical fiction about somebody very like himself who lived in a stone cottage in Wales and taught tantric yoga. And the central character, Wizard Prang, can, for example, levitate. Beer talks about this in very kind of self-deprecating ways, as if he could do that, but you don't need to make a big fuss about it. Another dimension of this, which might be easier to grasp, is that if you think of the world as a source of inexhaustible becoming, novelty, originality, in a performative sense, the world is always capable of doing something which would surprise you. It seems to me to restore you to a kind of state of almost childish wonder and awe, right? I actually used to feel this when I was a schoolboy learning physics. I was very interested in the world. And this comes across very strongly in a lot of work in cybernetics. The biological computing project. You would only arrive at the idea of using a pond to manage a factory if you had a strong feeling for the liveliness and the potential of matter. Stafford Beer tried to express this by writing poems about, for example, the computing power of the Irish Sea, which he illustrated in a very interesting book called From Pebbles to Computers, The Thread, right? And it's all about the computing power of the material world itself. This seems to me to be an interesting kind of quasi-spiritual attachment to nature at the performative level, which is completely different from the kind of surgical, forensic attitude of the physicist who just wants to take everything apart and find the fundamental bits. As well as seeing the world as a place of inexhaustible, unpredictable becoming, it follows rather naturally in the cybernetic tradition to see ourselves as in all sorts of ways capable of surprising performances. One surprising performance would of course be levitation or telepathy that the cyberneticians were very interested in. Another form would be, different forms of the self. If the modern self of you and I is a kind of bounded thing, it's a reliable, enduring centre of agency. I'm always pretty much myself. You might think, well, maybe there are other ways to be, right? And maybe those other ways to be could be interrogated through different technologies of the self, as Michel Foucault called it. So in Beer's Buddhist practice, meditation was very important. Meditation as a way of undermining the modern self and entering into an altered and what people would call a spiritual state. This is the whole point of Buddhism, of course, to dissolve the modern self, to be there in the world, which goes with this attitude that I call hylozoism, which comes back as biological computing, or Beer's model of the adaptive organization, or Pasque's musical machine. All of these things are very easily connected to one another. They don't have to be. You can kind of pick one bit and not have another bit if you don't like. But I'm very interested in the way that spirituality and down-to-earth engineering and robotics and worldly psychiatry, for example, can all run into one another rather than existing in separate realms.